The simulator illustrates the relativistic mechanics of high-energy particle collisions and demonstrates how the efficiency of matter creation is fundamentally determined by the chosen frame of reference. In the center of mass, frame, particles collide with equal and opposite momentum, allowing 100% of the available system energy to sit at the precise base of a hyperbolic invariant shell and efficiently transform into heavy exotic states, such as a Higgs boson or a dark matter candidate, provided their specific mass-energy thresholds are met. When viewed from a boosted laboratory, fixed target frame, however, the target particle begins at rest, requiring the incoming beam to carry exponentially higher energy to achieve the same physical outcome. This induces a severe energy penalty where a massive portion of the initial energy is wasted as bulk, post-collision forward kinetic motion rather than being converted into mass. Crucially, while individual values of energy and momentum shear and expand dramatically depending on the observer's boost, the total invariant mass squared remains perfectly conserved and locked to its hyperbolic trajectory throughout both the initial collision and the subsequent isotropic or missing energy particle decay tracking windows.